Hi everyone. Let's continue with other concept called joins. This is most important concept, especially in the form of interviews and even in GATE as well. So let's pay attention, guys. Joins. You all are familiar and comfortable in fetching data from single table, but in most of the cases, you have to fetch from multiple tables. In such case, joins is the only option. Totally, we have 8 types of joins. First one, Cartesian product, equi-join, non-equi-join, self-join, left outer join, right outer join, full outer join, and natural join. So we'll cover all 8 joins in detail. I'll not cover any theory perspective. I'll focus only on query solving ability. Let's continue, guys. Let's start with Cartesian product. Let's check 2 tables, guys. The first table being employee, other table being department. If you take employee, the Cartesian product will be denoted by cross. If you take employee, how many columns, guys? We have 5 columns and how many rows? 3 rows. Similarly, if you take department, you have 2 columns and 3 rows. So these are the 2 tables that you need to perform Cartesian product. Now, as Cartesian product contains 2 tables, let's denote EMP with black and department with red. It consists all columns, 5 columns of employee and 2 columns of department. Now, how about rows? What is the theory perspective? All rows of first table will join with all rows of second table. That means all rows will join with these 3 rows of this table. Now, what is the end result? How many rows will come? Anyhow, columns are 7, pretty clear. How about rows? Look at this. If we take first row in employee, it will join with all 3 rows. So, employee number 1, you will find 3 times in Cartesian product. Look at this. 3 times. First appearance with 101, second appearance with 102, third appearance with 103. So you will find employee number 1 3 times in Cartesian product. Similarly, employee number 2 also you will find 3 times. Similarly, employee number 3 also you will find 3 times. So ultimately, number of rows in Cartesian product will be 3 into 3, that is 9. So the final output of Cartesian product is number of columns will be added and number of rows will be multiplied, guys. So here is the total result of Cartesian product. So whatever data you require only subset of this. You will not get even 1 row extra from this. Out of 9 rows, whatever query you write, you always fetch a subset from this. So this is clear with Cartesian product. In order to understand the other 7 joins, which are subsets of this, we'll take 7 different queries. First, we'll go through tables. Let's check employee table, which consists of all employees, department table, which consists of all departments, and finally the job grades. Basing on salary, grade will be given. Basing on salary, the grade will be given, guys. Requires 3 different tables I have taken, and 7 types of joins will explained by using 7 queries. Look at the first query. Fetch employee information along with department information. Fetch employee information along with grades. Fetch employee information along with managers. Fetch all employees along with their department. Similarly, the last join natural. Let's go ahead with one after the other. Start with first one. Here is the employee, here is the department. Fetch employee information along with department information. So ultimately, what output you require? Look at this. Here is information. Here is the department number. I have only department number employee, but I need department name as well. For that, you have to join these two tables. So number of columns will be 7, number of rows will be 9. Ultimately, I require output in the form of this one. These three columns are available in employee table, whereas it is the only column which you need to fetch from department table. So ultimately, you have to go for Cartesian product. Look at this. All rows are clear. Cartesian product 9 rows. Among these 9 rows, you need these 2 rows. Please identify which 2 rows are giving this result. Look at this. Employee number 1 working in department 101 joined with all departments. So if you want to fetch name, you have to join with only your department, not all departments. That is the logic you have to identify. So you need first row. Let's call this as EMPE. This called DEPTD only for naming convention. So you need first row. Next, employee number 2 working in department 102 joined with all departments. So which department you require? Only this one. Please join with only one department, only your department. This you require this row. So anyhow, employee number 3 is not at all working, so you can ignore him. You can ignore him. Ultimately, you need only these 2 rows. How to get these 2 rows? Here is the condition. If you consider this entire Cartesian product as single table, what is the query to fetch these tables? I call this as E, this called D. So E dot D number is equal to D dot D number. So here look at this. Employee E is called and department D. What is the logic? E dot D number is equal to D dot D number. So whenever you perform join using equality operator, that is called as equijoin. That is called as equijoin. Here you join two tables. That's why you used one condition. If you join 3 tables, minimum you have to use 2 conditions. If you join 10 tables, minimum 9 conditions. Maximum can be infinity, guys. So ultimately, to join n tables using equijoin, minimum number of conditions must be n minus 1. That point you have to understand. That is with equijoin, guys. Joining 2 or more tables using equality operator. This happens mostly with child column and parent column because it is a foreign key to this column. D number is a foreign key referring to this column. So it always happens with the child and parent. Now, continue with next type of join. Here is the employee. Here is the job grades. That is, basing on salaries low and high, grades will be given. Now look at employee number 1. What is salary? 500. Which grade he belongs to? A. Look at employee number 2. Salary 2,500. Which grade he belongs to? B. 3. 15,000. Which grade he belongs to? He is between this. So basing on that. So ultimately what information you require? Look at this. These 3 columns anyhow I found in employee table, but this column is available only with job grades. So I don't have any option left, guys. I have to perform Cartesian product. Here are the 9 rows. Now tell me which rows are required. Call it as E and call it as G. So employee number 1 joined with all grids. Now what you have to identify? Please don't join with all grids. Please identify which grade is yours basing on your salary. So ultimately 1 with 500 belongs to this grade. Similarly, this one required. How about 2? Employee number 2, salary is 2,500. He too joined with all grades, but he doesn't belong to this grade. He doesn't belong to this grade. He belongs to this grade. So you have to get this. Similarly, employee number 3 also you please identify. Employee number 3 joined with all grades of salary 15,000. Please identify your grade. Sorry, my salary doesn't belong to this. My salary doesn't belong to this. Yes, my salary belongs to this one. So please identify that. So if I call this as E, this as J, what is the condition? Please consider this as single table. What is the condition? E dot salary between J dot low and J dot high. Either you can write between, or you can write E dot salary greater than equal to and less than equal to. Here used conditions other than equality, maybe greater than equal to, less than equal to, not equal to, whatever condition you use, that kind of join will be non-equijoin. Joining two or more tables using an operator other than equality is called as non-equijoin. Let's continue with the next join. Here is the employee table. Look at this. Fetch employee information along with their managers. Guys, employee number 1, what is his name? A. Anyhow, he doesn't have manager, leave it. Employee number 2, what is his name? B. Who is his manager? 1. And what is his name? A. Similarly, employee number 3, what's his name? C. Who is his manager? 2. What's his name? B. So ultimately, the information is available in the same table because this column is a foreign key to this column. In such case, please take another table. Ultimately, I need information like this. Employee number, here is the employee number, 2 and B, and manager 1 and A. So please show results like this. In such case, employee and manager in same table. That is a foreign key referring to another column in same table. In such case, please take the same table. Consider this as employee, this as managers. Now ask all employees to join with all managers. Yes, done. He is one employee. Anyhow, he doesn't have manager, leave it. He doesn't have manager, leave this row. Next, continue with this. Employee 2. His manager? His manager is 1. He joined with all managers. Now I am requesting, please join with only your manager. Don't join with other managers. What is the condition? This manager number must be equal to that employee number. So this is required. These two are required. Similarly, here also the same thing. Employee number must be equal to manager number. The condition is E dot manager number is equal to M dot E number. That is the way to write the condition. Clear, guys? In this case, look at this. This is also equijoin, but the only difference is both tables are same. Performing equijoin on same table itself, that is called as self-joining. Joining a table to itself. It is also type of equijoin wherein which child and parent are in the same table. In such case, we go for equijoin. Sorry, self-join. The next join. If you want to understand left outer, right outer and full outer joins, those are outer joins. First, you have to understand equijoin first. Guys, if you go for equijoin, you are joining using equality operator. Yes, fine, understood the condition. Now, how many employees are there total? Total you have 3 employees. How many departments? 3 departments. But how many employees are coming in equijoin? Only 2. How many departments? Only 2. What are missing? Because 3 hasn't come, 103 hasn't come. Reason is 3 doesn't have department and 103 doesn't have employees. So there are 2 types of employees. They are called as working employees. It is called as free employee. Similar 2 types of departments. These are departments with employees, these are free department. So whenever you go for equi-join, so you will get all working employees and you will get all departments having employees. You will never get this row, that is free employee, and you will never get free department. If you want free employees or free departments or both, the only option is you have to go for outer join, which is an extension to equi-join. Let's continue. Look at this. It's highlighted because he is a free employee, not working in any department. Look at the query. Fetch all employees. I want every employee to attend along with department information. If you have department, show it. Otherwise, show as null. I need query like this. In such case, you have to go for outer join. Here is the condition part. What is left outer join? Left says rows of equi-join plus free rows of left table. Here are the rows of equi-join, you know that. What you require? Free rows of left table. Whichever table you place on the left side, that free rows will come. That is a free row of left table, because look at this. I have written left outer join. On left side, employee table has been written. So I'll get rows of equi-join plus free rows of left table with right table information will be null. Similarly, if you want free department information, you have to go for right outer join, or you can swap this. Look at that. Right join. Fetch all departments. The same concept, guys. This time, rows of equi-join plus free of right table. It is also extension, guys. Next, at times you require both free employees and free departments. In such case, full outer join. Rows of equi-join plus free rows of left table plus free rows of right table. For left table, right table information will be null. For right table, left table information will be null. That is called as full outer join. The last type of join, which is called natural join. In order to understand this natural join, please be clear. R has how many columns? A, B and C. S has B, C and D. Now look, R natural join S. No where condition has been written. I simply placed R natural join S. All previous types of joins I included where class. Whereas in natural join, I'll never include any where class. Natural join says it is also a type of equi-join, but where condition will be constructed automatically on similar columns. Between these two tables, how many columns are in common? BC. It is nothing but equi-join on similar column names. It is also a type of equi-join wherein where condition need not be mentioned. So what is the condition? Columns BC. So this condition will be constructed along with AND class. Here is the condition. Please execute the query. What are the conditions? On 9-row Cartesian product, you have to select the rows where these two conditions will be satisfied. Yes, second condition. Yes, done. This way is selected. Sorry, this one. Row by row processing failed. This one failed. This one failed. Here, yes, and yes. So this is selected. Likewise, if you continue, only 3 rows have been selected out of 9. The beauty of natural join is common columns will appear only once in the result. Though B and C appears in both tables, yet in the result it comes only once. So result will be only A, D and common columns only once. That is natural join. Now somebody argues with me by writing this. Sir, can't I write natural join in this way? Yes, you have written conditions, but it is not a natural join. So common columns will come twice in this result. Common columns will come twice in this result. Though number of rows are same, the difference between natural join and equi-join will be There are only one similarity, that is number of rows will be same. Two differences. First is here you have to write where condition. Here there won't be any where condition, and here common columns will come only once. Here it comes twice. Clear? Yes. Now let's go for summary, guys. So I hope it is clear. You understood the difference between natural join and equi-join. Both are same, guys, but in natural join, you do not mention the where class, and columns will come only once. I think you guys are familiar with all 8 types of joins: Cartesian product, equi-join, non-equi-join, self-join, left outer, right outer, full outer, and natural join. Now, you have to understand few exceptional cases in natural join. I think you already know all exceptional cases will be gate questions. Say the first case. Two cases you have to understand. First case, there are no common columns in both. R has two columns, A and B. S has two columns, C and D. What happens if I write R natural join S with no column in common? As there are no common columns, so where condition will not be constructed. The end result will be all rows of Cartesian product will be selected. That is the first case you have to remember. The output of natural join with no columns in common, the end result will be Cartesian product. The second case, look at this. There are one column in common, but data types are different. It is character data type, it is integer data type. If you write the correct condition, you will get an error message. You are trying to compare different data types. So these two are the exceptional cases you have to understand. So let's have a briefing, guys. Now I'll show you let's do reverse mapping. I'll write a query. You please tell me what kind of join is it and how many rows will come. Look at this. R1 having two columns with two rows. R2 having two columns with two rows. Yes, tell me what kind of join is it? No where condition. So obviously it is Cartesian product. How many columns will come? How many rows will come? Number of columns will be added. 2 plus 2, 4. Number of rows will be multiplied. So ultimately 4 by 4. Now, so what kind of join is it? Equality operator. This is equi-join. Guys, please always try to simulate Cartesian product. Whatever number of tables you see in where condition, don't see all tables differently. Please visualize Cartesian product. Always visualize Cartesian product. Number of columns will be added, number of rows will be multiplied. To execute this query, I am visualizing this. Total, I have to process 4 rows, checking this condition. R1.A, yes, first row. Yes, selected. Second row, R1, eliminated. Third row, it is 3, it is 1. Again, eliminate. Fourth row, again, eliminate. So I processed 4 rows. Only one row matched this condition. So only that row will be selected. That is called equi-join. What happens if I write natural join? Natural join is also a type of equi-join wherein which common columns will come only once. Only once. Clear? Yes. This time left outer join. Left outer join. Understand the concept carefully. Left outer join is nothing but rows of join, rows of equi-join plus free rows of left table. Free rows of left table. The free row, 2 rows are there. This one participated. This one participated. How about this one? Not participated. So obviously this row will come. This row will come. So you'll get 2 rows. One with equi-join plus this one with the right table information will be null, guys. Similarly, this time right outer join. The same extension. Free rows of right table. It is the participated row. So what is the free row? This one. Plus free row of right table. This one. Look at this. Now the next one, it is full outer join. Outer join means all together. Rows of equi-join plus free rows of left table and free rows of right table. So basing on that, you have to solve the queries, guys. All joins, the base is Cartesian product. From that equi, non-equi, left outer, right outer, full outer, everything you can write it, guys. Comfortable? Yes. Now, at times you will see full natural outer join. So don't be panicked, guys. All are same. Full natural outer join is nothing but a full outer join with natural. That means perform full outer join and write common columns only once. Natural outer join. There is one. Plus free rows of left table. Plus free rows of right table. That's it. That is full outer join. Full natural outer join. All are same, guys. Everything comes from Cartesian product. Clear? Now key points. Whenever you want to fetch data from multiple tables, please always visualize Cartesian product. From now on, never ever say there are multiple tables T1, T2, R1, R2 in from class. Always say there is only one table which is Cartesian product. Number of columns will be added, number of rows will be multiplied. You know the difference between natural join and equi-join. In natural join, where class will be constructed automatically and common columns will come only once. Look at this. If number of rows in EMP 12 and DEPT is 0, how many rows will come? What kind of join is it? Whenever you don't see any where class, it is Cartesian product. If it is multiplication, 12 into 0 is always 0, guys. Don't say 12. Each row in employee has to join with all rows in department, as there is no row left in department. So nothing to join. 12 into 0 is always 0. Look at this. Number of rows in EMP 1000, that is child table. Number of department 2000. What kind of join is it? Equi-join. When minimum comes, when maximum comes. This question you need to answer carefully, guys. Now, minimum and maximum. Please see the case, observe carefully. What is the minimum? The entire logic depends on foreign key, yes or no? Here is the foreign key. Here is the foreign key column referring to this table. In this example, as 1000, 2000 impossible, I have taken 3 rows in child table and 5 rows in parent table. If you observe, this row will join with all rows of, one second guys, let me erase this. In Cartesian product, this row will join with all rows department table. Now what is the condition you have to verify? E dot d number is equal to d dot d number. As there is no d number, so you are not a working employee, so you will never be selected. Similarly, here also you will never be selected. Here never be selected. By default, a foreign key column accepts null values. If all are free employees, then the end result will be 0. End result will be 0 rows. No rows will come. So when you want to get maximum, maximum comes only if all are working employees. All are working employees. If every employee is working, this one join with all 5 rows and only one combination will be selected. And here also one combination, here also one combination. So altogether only 3 rows will come. So minimum always comes from foreign key table, that is child. So minimum always comes from only child table, guys. So what is the minimum case? Minimum case will be 1000, guys. I hope you are clear, guys. For equi-join, the logic is happening between child and parent column. Child and parent column. So if all are working employees, maximum comes only from child table. If all are free employees, minimum will be 0. At times you will get one more thing. child table which is foreign key plus not null. That means foreign key column will never take null values. In such case, minimum maximum will be not null means all our employees minimum maximum will be only 1000 because all are working employees. Look at this, all are working employees. So every employee will be selected only once. So minimum and maximum will be 1000. Yes, free. So last question. Number of rows in EMP will be M. Number of rows in DEPT will be N. Now what kind of join? No join specified, just a join. It can be any one among 8 joins. Minimum, maximum. Minimum will be 0 guys with equijoin, no rows matching. What is the maximum? Maximum is always the Cartesian product which is M into N. Clear guys? These are all the key points you have to remember while solving GATE questions. I hope the concept is clear for everybody. Now let's continue with the first question. There is a question given in GATE 2011 for 2 marks. Look at the query please. Just pause the video and see the query. Let me explain. There are 2 columns, borrower, 3 columns, borrower, bank manager and loan amount. What kind of join? It is natural join. One table is S, other table is T. They are asking you to count. Let's get into the query first. Let's identify what is S and T first. What is S guys? S is borrower and bank manager. Borrower and bank manager, it is S. Now what is T guys? Is bank manager and loan amount. This part is T guys. T. Now what join you have to perform? Natural join. Whenever you want to perform natural join, it is nothing but equijoin on common column names. So it is that. You can see 4 columns with 9 rows. Please identify common columns, equijoin, this one. Here is the condition you have to verify. First row mapped, second row no, third row yes, fourth no, fifth yes, sixth no, seventh yes, eighth no, ninth yes. 5 rows selected guys. So answer will be 5. This is the way you can solve using Cartesian product, but it's a tedious process. So please never do that. Always start visualizing Cartesian product. For example, in like this. Here is S, here is T. So ultimately you have to process 3 into 3, 9 rows. This row will join with 3 rows. Now execute the condition. Is S dot bank manager is equal to this? Yes. So this combination is selected. Now how about this? No, this combination failed. How about this? Yes, this combination selected. So ultimately 3 rows processed, 2 selected. With this row is completed. Next, this row will join with 3 rows. First combination failed, second combination selected, third combination failed. So this one selected. 6 rows processed, 3 rows selected. Now the last one. This will join with 3 other rows. Again, first combination, second combination failed, third combination selected. So ultimately 5 rows selected. This is how you have to visualize Cartesian product. So never ever say there are multiple tables. I hope you understood the concept. Please go through once again. I wish you all the best. Thanks a lot guys. That's it for today.